Problem 1920, build array from permutation. So to solve this problem, we need to do some clever thinking with divide and modulo, and as it pertains to CS. So any number divided by a number that's larger than itself will result in 0. In short, it's always going to be the dividend, or whatever is right here. And in Python, that is a double, right? Anything that's divide will result in a double, but if we do double slash, it will result in an int. But that's just a small subtlety. The modulo it works exactly how it should. It gives the remainder. So 3 modulo 1000 gives 3. With this, we can solve the problem. So we want to solve this basically in O of n time and O of 1 space. And what that basically means is that O of 1 space means that we have to manipulate the array we're given without using any extra data structures. O of n means that we can only iterate through the array once. So how do we do that? Well, what does divide and modulo do? Well, actually, what does divide and multiply do? Divide and multiply cancel each other out. So perhaps we can store information within each array index by adding multiples of each other and taking the modulo of it. And what I mean by this is, consider 0. Let's do 0 plus 1024 times n of 0 modulo 1024. And why do we do this? Because remember, x plus y divided by a is equal to x divided by a plus y divided by a. So it means that we basically preserve information by adding, because one piece of information stored is going to be the original array value, and the other piece of information stored is going to be what the new value should be to occupy the original position. We add it to preserve the two pieces of information because of this rule. And why do we do this? How do we restore the updated value that should occupy the 0th position? Well, we're going to divide it by 1024. And I'll tell you why I chose 1024 in a bit. But we'll do this. We're going to divide by 1024 for everything, like so. And what happens? Well, by the above rule, this becomes 0. And 124 cancels. What we're left with is n of 0, remainder 1024. Now, I chose 1024 because 1024 is going to be larger than all the possible values that are going to be within the array. So the array, I believe it tells us that the n is going to be within 0 and 1000 inclusive. I could be wrong, but basically I chose a number that's larger than the upper bound right here so that we can use the rule right here, that anything divided by a number larger than itself will give 0. So what this means is that this term goes to 0, so we eliminate the original term, and we preserve the original, which is, since this is always less than this number, it would always give back n of 0. And that's it. We basically were able to just perform arithmetic to preserve both pieces of information while achieving the task. And you'll see this in action in Python. Well, first, we're going to need to iterate through the entire array. So for I in range is 0 to the length of nums. What can we do? Well, we're going to say that the current element is going to be equal to the number of itself plus 1024 times what? Times nums of I modulo 1024. And 1024, you could choose 1050, any number that's larger than the upper bound of what the values in the nums can be. And we add it because how are we going to restore the n information? Well, for I in range is 0 to length of nums of I is going to be equal to nums of I divided by 1024. Because, as we said previously, nums I preserves the information about the original value. And again, when we basically do this operation, we need to modulo 1024 because the value at nums I could have been modified prior to using it. So modulo 1024 basically gets rid of the 1024 that we multiplied to nums of I, and it leaves us with the value that should take the place of nums I in the end. And we restore that by dividing it by 1024 to get rid of the 1024 that we multiply to the value that should occupy this space. And with that, we can simply return nums, and we're done. So let's run it. I don't know why that's happening. It should work though, so let's just submit. And there we go. That's the solution.